Uh, Welcome back to once again. Welcome back. So, if you haven't subscribed to the channel, please subscribe. Let's go to content. Today, in a last session, we looked into removing duplicates from sorted array. So, we hope you already familiar with how we are using it. So, we have used two-pointer approach, one pointer position for non-duplicated, one position zero. Another pointer is for to find a non-duplicated element. The next non-duplicated element. So P1 is basically the position where we will replace. In last session, I explained the next concept, which is basically removing element problem. So comes to the problem side. This problem is also a two-pointer approach. So let's read the problem again. So given an integer array nums and integer value, remove all occurrences of val in num. And you have to do the operation in place, which means you don't need to, the requirement here is don't copy the content into another array and do that operation. So the order of the elements may be changed, then return the number of elements in the nums which are not equal to val. So you can change the order of the elements, but you just need to return the size of the nums which are not equals val. Means here, okay, let's go to the example and you can see that. So consider the elements in nums which are not equals to val. Pick A. To get accepted, you need to do the following things: change the number such that. So this pretty much the input details which is providing is the summarization of this input details is nothing but you have to do the operation in the nums. Means don't create another duplicated array to perform any operation, and you have to return number of elements in the nums which are not equals to val, so that it just read the test code basically read that nums until the given length, and it compares whether that elements are expected or not. So here in this example you can see 3 2 2 3, where val equals to 3. You have to remove the value 3. So ideally, if we remember, you have to shift this 2 to forward direction, right? So if you remove this 3, the 2 in index 1 has to move to 0th index position, and next 2 in index 2 has moved to this position, and remove this 3. So let's see this the first problem which mentioned here. So the given array has 4 elements, 3 2 2 and 3. When we are removing elements from the content, so basically the expected output, if you see, so first you have to replace this 2 to 0th index position 3. So remove the 3, move the 2 to here, so it's going to be like a 2 and again 2 2 and 3. In the next iteration, what we need to do here is your cursor will go to the next position. Here it is a 2. This 2 has to go to this position, right? Because you are as you are removing a 3 element, so each element has to move forward 1 position, right? So if we do that way, so ideally what mean here is when you are removing 3 in 0th index, this 2 has to go here, and this 2 has to go here, and this 3 has to go here, and you have to replace 0 at the last position. So it's like a brute force approach. So if you do that way, so end of this loop statement, so you will get the complete content in the array like this: 2 2 3 and 0. Now in the next iteration, because 3 is already there, you can remove that again, which means because 3 is there, you have to move this to here, right? and then replace last element with 0. So this indicates you will get 2, 2 and 0 and 0. That's it, right? So this is what something like shifting each node element one by one. So if you remember this is like a brute force approach, and the complete time complexity will gonna be order of n square. The reason is you're gonna go to each element. I mean, like for every element you have to travel entire array, and you have to move each element one position, right? So that is the one approach, but it takes order of n square, so it's not going to be in a optimal solution. This is a good brute force approach, but the better approach we can solve by using optimum approach, by using two-pointer algorithm. So if you remember, in the last time I explained that two pointers algorithm is a very important concept in arrays problem. So please, if you get some time, try to practice as much as possible using two pointers, because pretty much most of your array questions comes to like two, I mean one of the pattern is like a two pointer, sorry. Yeah. So for this, how we can do that two pointers approach for given input, like a 3 2 2 3, right? So how do we can do this like a two pointer approach for 3 2 2 2 3? So pretty simple. We can do two ways. So what we can do, let us define two pointers. The p1 is a one pointer which gonna gives us like the position of our value. Okay, so here in this condition the value is a 3, right? So you need to get, so whatever the position of the value in the p1, let's do the p2, which is going to be pointer p2, which can tell us that like replacement position. So what I mean by replacement position, let's do replacement position. So what is the meaning of replacement position here is, it is a pretty simple. So one pointer gonna tell you like you have to, I mean in this case the p1 has to tell you that like this is the position of val. Replace position will tell that like, okay, there is a 2 which is not equals to value, and just replace it. Okay, so simple, remember that. So let us assume in our example, in the same case, let's see, oops, sorry, let me do, let's do, so one simple example here we can do 3 2 2 and 3. Let's assume p1 and p2. Initially both are allocated to 0, which is nothing but 0th position. So now what we're gonna do here when we do see, so the first step, you see, if p1 equals to position of value, means like is p1 is equals to val, yes, in this condition here, right? If the number of p1 equals to value, so if the number of p1 equals to value, what I'm gonna do, I'm gonna replace the next position which is not equals to val. So here in this condition the not equals to val is 2, right? So here number of p1 is equals to number of p2. But here before jumping into this problem, you have to make sure that p2 is not equals to val, means like a p2 position must be not equals to val. So how do we can do this kind of operation? Okay, let's do this way. I'm gonna put I'm gonna run this while loop until end of the statement. So while I'm running this, okay, this condition you have to run it in loop, that's it. So you have to find p2 where value is not equals to null, and if p1 value equals to null, we just need to replace that p1 and p2 values, and we need to just increase that p1 and p2 both. So ideally if we run this loop, I mean if we run a loop or while loop, and we take that index as a p2, then we can solve it. So what I mean here is we can run a for loop where I equals to 0 to the complete nums, all the num values from 0 to each index position. When we are doing this one, you can check if number of p1 is equals to val. So what we can do here is we can replace with that number of p1, or else let's do this one second. Let me do this approach. Let's write this approach, and then I will try to explain that what I'm trying to do here. So I'm gonna write one for loop for int I equals to 0, I less than nums dot length I plus plus. Okay, so my I will be one, one of the pointer. So what I'm gonna do, if num dot of I is equals to val, okay, if my nums dot value equals to val, let's take another pointer, int pointer equals to let's assume 0. Okay, so what I will do, okay, let's do this way. If nums not equals to value, so when I'm iterating through this loop, if it is not equals to val, I'm gonna replace nums of pointer equals to nums of I. And then I'm gonna increase my pointer. So what I'm trying to do here, let's erase this complete part. So what I'm trying to do as the input here is, so I'm iterating through my entire loop one by one. I'm keeping one pointer, which is a pointer value. So here my index I is acting one pointer, and the value pointer which is defined in third line is a second pointer. So I'm keep on looking into that. When num of I not equals to value, means like if value not equals to value, here like a value is a 3, right? So 3 and 0th position is not equals. So what I can do here, let me write it down here, and let me try to explain that what I'm trying to do so that you get some idea. Okay. So let's do this. Here we'll do what I'm doing here is like I'm keeping a pointer which is a 0th position, and then I'm taking 3, 2, 2, and then 3. Okay, so my index position where I equals to 0. So I'm considering the index position I0, and every time I'm iterating. When I'm iterating to that, I'm just looking into whether this value is equals to the comparable value. So if this is not, so when 0th index position 3 is equals to 3, so you don't do anything. Go to the next position 2, which is nums of I, where I is a 1 now. The 2 is not equals to value, which means like this is not 3. So what I need to do, I need to forward this 2 to the P0 position. So the P0 position is a 3, right? So I'm gonna replace this 2 with here, and then I'm gonna do P++. the pointer plus plus. So ideally it's gonna go to pointer equals to 1, and your input array will be 2. Still you have a 2 here, you have a 2 here, you have a 3. So we are not moving all the elements, only we are replacing wherever 3 is there, wherever our value is there, we're just replacing that. So currently the I value is a 1, and you know that val is still 3. So now in a while loop, I plus plus, so I will be 2, that means this is the value. Okay, now again you are comparing with that whether this is not equals to value. So this is a 2, but this is a 3, right? These are not equals, num of I not equals to value. Yes, yeah, this is not equals to value. Nums of pointer I, which means this position, first position, you have to move. So that's what we are doing here. Nums of I, the I position, which is a second position, has to go to P position. So it will be replaced with the 2. So this will go to P plus plus, P will be 2, and the result will be 2 and another 2, then 2, 3. So ideally the result is same, but what we did here is like we moved that this index position to here. Now I will be in the next iteration 3, val is still 3. So when we are coming to third index position, where nums of I val are same, so you don't need to do anything, you're just coming out of that. So once we are done with this entire operation, the P indicates the corresponding position, right? Like a P indicates, right now P is pointing here. So this corresponding position is nothing but the P minus 1 indicates the number of elements you have shifted forward direction. P minus 1 is nothing but is that there are 2 elements which are not equal to this value. So if you do that operation, you just need to return pointer minus 1, sorry, minus 1. So let's run the code. Okay, sorry, you are doing that pointer plus plus later time. So let's submit the code. I will walk through again one more time to explain this. See, sounds good. Let's come back and explain this code. It's a pretty simple. What we are doing here is like we are keeping 2 pointers. So in the third line, pointer 0, this indicates, you can see that this pointer is position like index position, where nums of pointer not equals to value. So in a simple single pitch, we can say like it is index position where pointer not equals to none. Then I is another pointer. You can say I is like a pointer to keep reading entire numbers sequentially. Then we are looking at nums of I not equals to val, then making that forward operation, which means like moving each elements one position, like the previous position. So why do you need to do this operation, if you can ask? So if you make the same program, let's do this way. So if you have let's assume you have some your input is like a very large one. Let's assume that. So assume we have 3 2 2 3 3 2 like this, and as usual our value equals to 3. So I'm gonna put index I here, okay, and then val here. So in this index I mean 0th position, let's compare with that corresponding val one. Sorry, the val is already there. Sorry to so initially I equals to 0, okay. So okay, yep, let's take I equals to 0. So what we'll do, let's take I'm making that p as a pointer, both are 0. Now when we are keep iterating to those two, let's take a one pointer where here 3 is a one pointer. Let's assume this is a pointer, and currently we have assume this is our p pointer, okay. Now what we'll do here, so when we are doing that this for loop, when we are iterating to that for loop each time, so num of I not equals to val. So ideally here I is 0, right? So when I is 0, so 3 is equals to val. So you don't need to move pointer to, I mean p pointer to further level, but just move that I pointer to next level. So which means I pointer move to one step ahead. Then you will compare that, okay, this 2 not equals to val. So you have to replace this value with your the pointer position. So pointer usually will tell you that where the next element has to be replaced, okay. So this one will be moved here, and then you can see the pointer will be moved to here. Okay. So ideally after this operation, your input will be simple. You'll get 2 here, 2 here, 2, 3, and 3, and 2. Now if you see I pointer here and then p pointer here, okay. So I and p are both. The next move your I value to next move your I value to the further level, which means here. Now check, it's not equal, right? Like the value, I mean 2 is not equal to value. So move that 2 to your previous p pointer, and then increase that p pointer to next level. Like so ideally this 2 will be, I mean this 2 will be replaced by this 2, which means okay. So what we'll do at the end of that loop, you will get 2, 2, and still the 2 is there, 3, 3, and 2. So let's go, the I value is, I mean the I value is keep on increase here, so I will become here. The p value is like this position, so p value will be here, okay. Now what we'll do, again I value not equals to val, but it's equals to val. So what we'll do, we'll move the cursor I cursor to I plus plus, which is nothing but here. Sorry, I will move to here, okay. I move to here. So, and again this is also again equals to val, so I will be to the next position here, okay. Now this time val 3 and 2 not equals, so now you have to move this 2 to the forward direction. Ideally it has to move to position p, and then you have to increase that p value. So which means this 2 has to be replaced here, okay, and then this has to go to p plus plus, like so. Ideally after this completion of done, I mean like after that operation is done, so we're gonna go this 2, 2, another 2, 3, 3, 2 is still there. But ideally what we are doing here is your p pointer is pointing here, as I value is go out of the index position. I is pointing here, right? Sorry, I is pointing here, right? This, is pointing to out of the array, right? So that means you you moved all non-duplicated all non numbers which are not equals to our val is moved to forward position. So that's why you can see that all these twos are at the forward position. Then you just need to return this pointer, which is nothing but number of elements, but as it starts with a 0 and 1 and 1, array starts with a 0, so that's 3 indicates 3 elements which are not equals to our val, which is nothing but 3. Okay, that's it. So if you think about this question, like where usually we will use this kind of problem or something like that. So assume you are using a mobile app where you have all the movies. Like let's assume you open a IMDb app and you have all the movie names like 1, 2, 3, 4, 5 like that, and you don't want to see certain movie. You can say like filter that movie name. Then it has to sort it that all the movie names has to be removed, and it has to go to display non-movie names. So such kind of operations required this kind of logic to implement. But remember, as you know that mobile applications require efficient algorithm as well as less memory usage. This could be one of the good example, we can say like this is one of the good example or good algorithm to implement in mobile device. So if you think about it, it's like if it is in a server, it's a good that you can implement in server too, because it uses less memory. But ideally, if we are speaking, it is in server you can memory is a cheaper, so you can implement normal order of n algorithm or of order of n square algorithm, but avoid implementing order of n square one. Brute force is only for to do like the first check problem or first solution which will spark in your mind like that. That's it for today. Thank you guys. Have a great weekend.